Welcome back, and today let's solve Leetcode problem 2843 titled Count Symmetric Integers. So we're given two positive integers low and high, and an integer x per se consisting of two n digits is symmetric if the sum of the first n digits of x is equal to the sum of the last n digits of x. Numbers with an odd number of digits are hence never symmetric. This is kind of a weird way of saying it, but really all they're saying is an integer is considered to be symmetric if the sum of the first half of its digits is equal to the sum of the second half of its digits. So we want to return the number, not the actual symmetric integers themselves, but just the number of symmetric integers in that range low to high. And again, this is kind of like the definition of how we compute if a integer is symmetric or not. So in example 1, we have our input integer low to be 1 and high to be 100. So in all the numbers in the range from 1 to 100, how many are symmetric? And in this case, there's actually a nice pattern to this. It'd be 11, 22, 33, 44, 55, 66, 77, 88, and 99. They're also, well, perfectly symmetric, also palindromic. I don't know if that's a word. And so since we have 9 different symmetric integers in that range, of course, we're going to have an output of 9, right? Notice how 1, 0, 0, and 1 wouldn't work because they actually have an odd length, meaning there's an odd number of digits in each of these integers. So in example 2, we have our input integer low and high to be 1200 and 1230 respectively, and in that range from 1200 to 1230, we actually have exactly 4. And when I say in that range, that's inclusive of these two integers themselves as well. Now the 4 symmetric integers in that range would be 1203 because 1 plus 2, the first two integers, or the first half of this integer is 1 plus 2, which is 3. 3 plus 0 is equal to 3, so 3 is equal to 3, so that is valid. 1, 2, 1, 2, that's equal to 1, 2 is equal to 1, 2. 3 is indeed equal to 3, so this is also a valid integer. If we had something like 1, 2, 3, 1, this wouldn't be valid. In fact, this wouldn't even be in the range. Let me give a better example of 1, 1, 2, 2. The first half of this kind of integer, if you will, is going to be these two 1s. 1 plus 1 is 2. The second half of this integer is 2 plus 2. 2 plus 2 is 4. 4 is not equal to 2, and so this wouldn't actually be a valid integer. So as you can see, 1221 also follows that property where 3 is equal to 3, and 1230 also does as well. Notice how they all have the same sum for the first two digits, or the two halves that are equal to each other, which doesn't necessarily always need to be true. So for the constraints here, we see that low is always going to be less than high, and they're always going to both be in the range from 1 to 10 to the 4th power. And really, this has a very straightforward approach, right? Like we see with many easy problems, there's a lot of kind of simulation problems where we really just deploy exactly what they're telling you and kind of just check them through conditionals and iterations or enumerations, and this problem is no different, right? As you may imagine, kind of like a solution that you may or may not have panned out in your head. Really, we just want to kind of go through all the numbers in that range from low to high. There's really no way around it, at least not in the most efficient process, because, well, we want to explore every single integer to check if it's valid or symmetric or not. And so we're going to enumerate over each integer in the range from low to high and check if it's symmetric. And that really is the entirety of the solution, right? That's kind of like the main observation that we really need to make. It's really just a direct simulation problem where we iterate through all the possible numbers and check if they're actually valid or not. I think the hardest problem is kind of like the syntax of actually checking and computing the sum for the first n digits, or the first half digits and the second half digits, and kind of simple syntax. So I'll kind of show you guys how that would work in Python, at least, using the map length and kind of data structure converting function to a string to get the accurate first and second halves, right? So we'll get the count. This is going to be 0. Now, what the whole point of this count is basically it's going to keep track of the number of valid integers, aka our output, in the range from low to high. That's the whole point of this count. We'll be incrementing it each time we actually encounter a valid or symmetric integer in the range that we iterate over from low to high. Now let's actually begin iterating. So for every single number or integer, if you will, in the range from low to high, as you may imagine, but in Python, the second parameter that we iterate over in for loops, it's always going to be exclusive. And so to actually include high in that for loop here, we're going to go up until high plus 1 or high inclusive. So for every single number in this range, we'll get the current element, we'll say s, and that's going to be the string of the current integer num, right? I could call this string num to make more sense, but I don't want to keep typing out string num every single time I have to reference this variable, so I'll just call it s. And the whole point of s is it's basically just the string data structure, or the string conversion of num. So if we had like the current integer to be, I don't know, 123, converting that to a string would literally just give us 1, 2, 3. That's all it is. And we take that 1, 2, 3 in the form of a string and store it in this s. And so why are we actually converting it to a string? Well, because that's actually a very efficient and easy way to get the first half and the second half of characters, because you can't really do something called list slicing in Python or any language that is with integers, but you can do them with strings. And so it's very important to do that to make our extracting the first n digits in a more efficient manner. Now, the first thing that we have to check is, of course, another thing is we can't really check the length or the number of digits in an integer. We have to use the length function only for data structures like strings, and so that's also why converting it to a string is a lot easier to deal with as well, right? So, first thing we have to check is, okay, does this current element, does it even have an even number of digits? Because we know that any number or integer with an odd number of digits or an odd length in the form of a string, they're never symmetric. And so that's the first thing that we have to actually consider. If the length of the current string form of the current element num, or integer num, if it's modded by 2, or rather if it has a remainder when it divided by 2 that's not equal to 0, that means of course it's not divisible by 2, i.e. it doesn't actually have an even length, it has an odd length, and if that's the case, we don't even care about this. We don't even want to keep performing operations on it. We don't even want to continue checking if it's valid or symmetric or not. We just immediately want to continue on to the next iteration or the next number in this range from low to high, right? Because of course we know, or we're guaranteed, we're told in the problem statement that odd length integers or odd digit integers, they're never going to be considered to be symmetric because of course they don't have even length halves in terms of splitting them. So now we're going to do something called list slicing in Python. This is really the big point of why we actually converted the current element number to be a string, because we want to actually extract or list slice the first n characters, or the first half characters of the input string s, and list slicing is a great way to do that. So I'm literally just going to call it left half, or left for short, and it's going to be s indexed from the 0 index. So I don't actually need 0 to be the first parameter because that's kind of the default parameter in list slicing, up until half of the string, or rather half of the length of the input string s, which is the current element num. Now, I didn't actually define half yet. That's my bad. So let me just quickly define half. We know half is going to be literally just the half of the length of our input string s, or the current element num. So length of s divided by 2, just to actually efficiently get the first n, or first half characters, and second half characters in a very efficient manner. And so very similarly, the right half is going to be s, starting from half, except we're going to go until the end of the array, right? So here, the second parameter after this index, or rather after this colon, is going to be basically the last index. So we're going from the second half characters here in the right portion of this array, and the left sum would basically just be the first half, or the left half integers or digits in the array, or in the current integer num, starting from index 0, going up until index half, where half is, again, just the half of the number of characters we have, or the half of the length of our current string form of our current integer num. So, now that we've actually got the list of all the first half and second half characters stored in left and right, now we want to actually compute the sum of them and check if they're equal, to check if this is actually a valid or symmetric integer. So, we'll get the left sum. And how do we actually calculate the left sum of this list here? It's actually going to be using the sum and map function. So it's going to be the overall sum of these first half characters. But how do we get that? Well, we're actually going to map each character to be an integer in left, and very straightforwardly or similarly, we'll get the right sum, basically the sum for the second half, or the right half of the current integer num. It's going to be the sum mapping each integer, or rather each digit in the left or in the right half to an integer. So what the map function does is it basically applies a function or a given parameter or data type to a given list or iterable, right? So here, effectively, in the left and right lists, we're converting each element in those lists to be an integer. We're mapping each digit in those lists to be integers and calculating the sum of all the integers in those lists, in the left half list and in the right half list. And once we actually get the sums of those two halves, if we know they're equal, meaning if left sum is equal to right sum, we know for sure that we've just found another valid or symmetric integer. And so we want to increment the count by 1 because this stores the number of symmetric integers that we find in the range overall from low to high plus 1. And so once we've actually iterated through all the elements in this range, or all the integers in this range, we'll return whatever count ends up being. So unless I made any syntax 0, 0, this should be accepted. This should be a valid solution. So let's go ahead and double check that. And as you can see, this really is just about as efficient as you can get it to be. And again, this problem shows why Python is really just the best language, at least in my opinion, subjectively, for DSA or Leetcode interviews. it has syntax that's very, very simple to deploy and kind of more tricky problems, at least syntax wise, because in other languages it'll probably be a little more kind of tedious to kind of get the first and second half characters of integers rather than strings or lists, for data structures, right? So what is the runtime complexity on a high level? What are we really doing here? On a high level, really, we're just iterating through each number in the range from low to high plus 1, or rather just low to high. We're getting the string formation. We're getting the first half characters and the second half characters of the current string using or the current integer num after we convert it to a string using list slicing and checking if the two sums of the first half and the second half, if they're actually equal. If they're actually equal, well, then we'll increment our count by 1, indicating that we found one more valid or symmetric integer in this range. Otherwise, we just simply continue on to the next iteration without actually incrementing our count. So what is the runtime complexity of this? Well, really it's just going to be big O of high minus low, basically just the number of elements or integers in the range of this. And memory complexity is really just going to be, on average, big O of 1. Why? Because really, technically, we're not actually using any auxiliary memory or any extra data structures. And so this is really just the most efficient solution that you can really get. You can't get more efficient than this. And so if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.